Hello everyone, welcome. It's the 9th video in the series. I'm glad you're here for it because this is a really important concept. I'm going to be going into how to add collisions to the game. Since most games use collisions, it's a really important thing to learn, so let's get right into it. So there are two different places where we need to add collisions. One is when you fire a laser beam, you need it to collide with a meteor so that the meteor explodes. And then the other one is where if you fly into a meteor, so the spaceship collides with the meteor, you want the spaceship to explode. First, I'm going to add the collisions between the laser beams and meteors, since it's easier to test that if you don't have to worry about crashing the spaceship into a meteor. So let's look at the move laser beams function. Inside of here, we iterate through all of the laser beams. I'm going to add to this loop, so in addition to moving the laser beam, we're going to also check if that laser beam's colliding with any meteors. So to do this, I'm going to go down and then add a for loop. So it'll be variable j equals 0, since we don't want to name it I, because then it'll be referencing the same variable right here. J is going to be less than meteors dot length, so that's going to be the number of meteors in the world, and then j plus plus. And then inside of here, just to make it simple, I'm going to declare a new variable called current meteor. And then I'm going to set that equal to meteors at the j position. So we'll get that current meteor we're looking at and then assign its reference to current meteor. The next thing that we need to do is check and see if the meteor is colliding with the laser beam. So I'm going to add an if statement. So if, and then the function that we're going to use is contains point. So current meteor dot contains point, and then we're gonna get the current laser beam, so which we've defined a reference for it right here. So it's going to be current laser beam dot x and current laser beam dot y. So we're checking if the current meteor that we're looking at contains the point where the laser beam is at. We need to remove the laser beam from the screen and the array. So laser beams, and then at the I position, we need to remove that. So dot remove I. So since we were using I, since we're iterating through the laser beams right here, so it's not going to be j because j is for the meteors. So we're going to remove the laser beam, and then we also want to remove current laser beam. So that is this reference up here. So we have the reference for the laser beam. And then the next thing that we need to do is create an explosion. So we're going to actually have a separate object for the explosions, and it's going to have a few frames so that it has some animation to the meteor exploding. So here I have the images for the explosion. This is the normal meteor right here, but here's explosion frame 1, 2, and 3. I only used 3 frames. I found it still looked pretty good since the animation happens pretty quickly. But of course, you can use more than that if you'd like, if you're designing your own graphics. But sometimes you might be able to get away with fewer frames than you might think. So yeah, if you go fast, you can kind of preview what that animation is going to look like. So back over to the code editor, I'm going to add those frames to the object map so they'll each get their own object. So I'll go ahead and do that quickly. You can find the URLs for the graphics that I designed on my GitHub page. So I'll post that in the description and you can just copy the URLs from there. Now that we've added the explosion images to the object map, I'm going to add some new arrays. Once a laser beam hits a meteor, we're going to create kind of a new explosion object that goes through each of the frames. So I'll have the array keep track of those explosion objects. So the first one is going to be called explosions, and then we're going to initialize that to an empty array. And then the next one is going to be called explosion progress. This will keep track of kind of what stage the explosion is in, and I'll also initialize that to an empty array, and I'll add a little comment here to show that this is the explosion segment of the code. All right, and then down here where we use the where we have the init game function, I'm gonna also initialize those to empty arrays so that we don't have any leftover explosions from the last game. All right, now let's go back down to where we do the move laser beams, and I'm gonna add another function called create explosion, or actually add explosion, and then inside of this function, we're going to take in 3 parameters. So it's going to be x, y, and rotation. So this is just the x, y, and rotation of the new explosion. So let's go ahead and create that new explosion. So we're going to say variable new explosion equals a new web image. And then for that web image, we're going to use the same image that we have in the object map. So I'm going to use the get image URL and then get the object map dot explosion 1, and then so we'll get the same web image that explosion 1 is using. The next thing that we need to do is set the x and y position and rotation of that new explosion. So I'm going to use new explosion dot set position, and then set that to the x and y position, and then also new explosion dot set rotation, and then set the rotation of that. Then we also need to add the new explosion to the array. So it's gonna be explosions dot push, and then new explosion, and then we also need to add the new explosion to the canvas. All right, now that we got that, we can also add to the explosion progress array. So explosion progress dot push, and then I'm going to push 0 since we've just added it, and then we're going to add to that explosion progress value the longer the explosion has been on the screen, so we can keep track of that and then change the different images of the explosion based on that time. So the next function I'm going to add to the screen is going to be called function move explosions. And then inside of here, we're going to take care of all the movement. So that'll just be moving kind of similar to the stars. So they're not actually going to be traveling in a certain direction. It's just going to move around to make the spaceship look like it's moving. And it'll be at the same level as the spaceship. So I'm going to add a for loop inside here. So for variable I equals 0, I is going to be less than the number of explosions that we have on the screen. So that'll be explosions.length, and then I plus plus. And then inside of here, I'm just going to add a reference variable to the current explosion, just make it a little bit easier to reference. So variable current explosion is going to be equal to explosions at the I position in that array. All right, and the next thing I'm going to do is move the explosion. So current explosion dot move. So this is going to be so scroll x minus last scroll x, and then scroll y minus last scroll y. So the difference in scroll x and scroll y. We also need to add to the explosion progress variable. So explosion progress at the I position, we're going to add 1 to that. So then we can keep track of kind of how long that explosion's been there. And then I'm going to add some if statements, so to kind of mark out different milestones of the explosion's lifetime. So the last thing that we want to do is have the explosion like disappear, but up till then we need to iterate through the other images. So I'm going to add if explosion progress equals explosion progress at I equals 5. That's going to be kind of the first stage where we change the image. So I'm going to use the current explosion dot set image, and then I'm going to set it to the next explosion image. So that'll be get image URL, and then of object map dot explosion 2. And then I'm going to do the same, except for change it to explosion 3 when it's at explosion progress of 10. All right, the next thing to do is remove the explosion, and I'm gonna have it do that when it's greater than, the explosion progress is greater than or equal to 15. The greater than is just to catch if for some reason it got bigger than 15. But then we need to remove the current explosion from the array. So I'm going to use explosions at dot remove, and then I'm going to remove the I position of that array. So that'll be the current explosion. And then I'm also going to remove the explosion from the screen. So remove current explosion, just like that. And then now we have something that will be able to cycle through the different images and move the explosions around the screen. We now need to actually create that explosion. So right here where we check the collisions with the meteors, right here you can see that if this is the if statement where we have the laser beam collide with the meteor, so we know that's collided. We need to create the new explosion here. So add explosion. We're gonna set the X, Y, and rotation to be the same as the meteor that we're replacing. So it will be current meteor dot X, and then current meteor dot get X, and then current meteor dot get Y. And also, actually, I should use get X and get Y right here, just to use the getter methods where I can. Also, earlier I made a mistake. I did meters right here. I made a typo. I didn't add the O, so make sure that it's meteors. Back here, so we're giving it the X and Y position of the current meteor, and then we also need to get the rotation. So remember, this is the function that we wrote earlier in the series. We're going to get the rotation of the current meteor. So that'll be also the rotation for the explosion. Then we need to remove the meteor from the screen and from the array. So I'm going to use the remove function. So meteors dot remove, and then I or J. So we're going to remove meteors from the meteors array, and then we're also going to remove it from the canvas. So remove current meteor. All right, now with all these things in place, let's run the code. So we got the spaceship flying around, and let's see if we shoot a laser beam at a meteor. Oh, almost forgot. Well, I did forget. We need to also add the move explosions to the loop right here. So I'll just add that at the end right here, so that we actually do move the explosions around on the screen. So I'm gonna fly over. Here's a meteor right there. Look at that. The meteors explode now when you hit them with a laser beam. Looks like there's an issue where they're just disappearing. So the reason the meteors were just disappearing without the explosion is because I forgot to remove the index in the array, so the explosion progress array. So all I need to do is add explosion progress dot remove, and then I. So what was happening before is it was reading an old explosion progress value, which would have been 15, and then just automatically removing the meteor because the old explosion progress wasn't removed. So now if we run that again, I'll bring that over, fly around to where there's some meteors, and if I fire a laser beam, you can see it works now. So that's pretty neat. We can fly and then launch the laser beams, and then the meteors explode when the laser beams hit them. The next thing to do is have the spaceship collide with the meteors. Before I write the code for that, I just want to show you a little bit of the theory behind it. So I'll make a quick diagram here. So let's say you have your spaceship, which looks kind of like that, triangular shape, and then you have a meteor. The thing that you need to do is decide like what parts of the actual spaceship and meteor will register a collision when hit. So there's going to be another collision shape that you use, and it's really hard to make it exactly the same shape as the sprite you're using, just because of the way the methods work. Like if you were to say get an element within the spaceship, it actually include kind of this box like right here, because the image of the spaceship like doesn't take up all the space of the actual web image. So normally what you do, and if you watch any other videos about making games, most of the time you make the actual collision shape a little bit smaller than the sprite. And this is helpful for the player, because if you make it bigger, it's just unfair to them, because they can see that the spaceship clearly didn't collide with the meteor. Let's say if you have that box example, if it collided right here, it doesn't look like the spaceship should be colliding with the meteor, but it might if you just treat the whole surrounding rectangle as the collision shape. So instead, I'm going to show you how to set it up to use circular collisions. And these are really nice because it's super easy to check for collisions if you just treat everything as a circle. So let's say I'll do this in green right here. Let's say you have the collision shape is just like this circle inside of the spaceship. So if any of the other objects collide within that circle, then it'll register a collision. And let's say for the meteor, it's kind of this circle right here. What you can actually do to check the collision is you look at the radius of each thing. So there's the radius of the meteor collision circle, and here's the radius of the spaceship collision circle. So if you add these two radii together, and then that number that you get, if the distance between the spaceship and meteor is less than or equal to that number, then you know that they're colliding. So I'll show you what that looks like. I'll just draw another meteor right here. So let's say the meteor just looks like this. So right here, I'll do it a little bit closer. And then the collision shape is going to be right here. So let's say it's that circle like this. And then the radius is right here. You can see that because when you add these two radii together, it means that the meteor is right on the edge of the spaceship. And of course, if the distance between the meteor and the spaceship is less, you know they're really on top of each other. So then if it's less than that distance, you can register a collision. So let's get into the code. So back in the code editor, we're going to look at the move spaceship function, or move ship function. And I'm just going to go to the bottom here and make a new little section for check collisions with meteors. And then I'm going to start out with a for loop. So I'm going to say for variable I equals 0. I is going to be less than the number of meteors. So meteors.length, and then I plus plus. All right, so the way we're going to check for the collisions is check the distance between the spaceship and each meteor. And if that distance is less than the radii of the meteor collision circle and the spaceship collision circle, then we know that the spaceship is colliding with that particular meteor that we're looking at, so we can register the new collision. And then that will ultimately end that game. I'm going to start out with adding a variable. So this is going to be called current meteor. So it'll just hold the reference to the current meteor we're looking at, just to make it a little bit easier. So that'll be equal to the meteors at the I position in that array. And then next we need to check if we're colliding with that meteor. So we're going to need to do a quick little calculation. So I'm going to use the get distance function that we wrote earlier in the series. So the first position is going to be the center of the screen, since that's where the spaceship is. So get width divided by 2, and then get height divided by 2. And then the next thing that we need to do is find the position of the meteor that we're checking. Now the meteor, remember, since the location is the top left corner of the web image, we're going to need to adjust for that. So by adding half the width of the meteor and half the height of the meteor, we're going to do that. I'm going to add, so current meteor dot get x, and then we're gonna do minus current meteor dot plus current meteor dot get width divided by 2. So we're gonna add half the width to manage that offset. So we're gonna be looking at the coordinates of the actual center of the image instead of the top left corner. And then I'll do something similar for the y. All right, and I just tabbed the if statement in here since it's a long line, and it'll run just the same. So that's something you can do to help if you don't have a huge screen. Right here, now we have the distance. So get distance right here, and that distance is going to be need to be less than the radii of the 2 circles. So we can calculate this. We need to decide something that looks good for the spaceship, and then decide something that looks good for the meteors. So just that distance to calculate. And the number that I came up with before is 50. So if you're 50 pixels away, it looks like a pretty good collision between the spaceship and the meteor. So the next thing that we need to do is remove the spaceship and that meteor from the screen. So I'm gonna say object map, or remove object map dot spaceship or ship, just like that. So remove the ship from the screen, and then we also need to remove the current meteor from the screen as well. So I'm just going to go ahead and remove it from the array too. So meteors.remove, and then and then also remove, and then current meteor. All right, so we're doing that. And then we also want to create the new explosion. So I'm going to use the create explosion function. And then we're going to give it the position of current meteor dot get x. So and then current meteor dot get y. And then current meteor dot get rotation of the current meteor. All right, and we don't have to offset the value of the explosion, since the explosion will just create at the top left corner. So it'll just replace the exact position where the meteor is. So now let's go over and run that and see how it looks. So if we fly around, well, the collisions between the laser beams work, but let's say we go and crash into it. Oh, it looks like create explosion. Oh, it's actually add explosion. I made a little mistake there. We'll run that again, and then fly into a meteor. Yeah, it's working. You can see we can still move around because you don't actually have to have the spaceship object there to move the spaceship around, but the collision works. It removes the spaceship from the screen, and so that's what we want it to do, so that's good. Alright, that brings us to the end of this video. Thank you so much for watching. I hope you all enjoyed and learned something new. In the next video, we're going to be wrapping up the whole project, so you'll have the completed game that you can share with your family and friends. So I hope you all come back for that one, and have a great day. Goodbye.